Level 3, number 5. This one is actually a little bit tricky. It's talking about a woman and her maximum power output. So it's giving us some information. It's saying the woman has a mass of 30 kilograms. And it says that her power output, or P, is 147 watts of power. Now, it says calculate the time it will take her to climb to the top of a 60-meter staircase, right? So here's the staircase. I'll just put a couple of stairs in there. It's 60 meters high, but each stair is 20 centimeters apart. 0.2 meters is the height of each stair. Okay. There's a couple of ways to approach this, and in the past, when this question has come up, I've accepted a couple of different answers. But I'm going to show you the way that a lot of people approached it, and then I'll show you why that's a little bit not quite right. Okay. Well, if we start with this power business, right? Power is equal to work or energy over time. The energy change or the work over time. So I can put both of those down. You can use either one. But this time, since we're talking about heights, that makes me think I'm going to look at gravitational energy. So what I'm going to do is I'm going to use this part of it. So I'm going to use that power is the change in, and what kind of energy is it? Well, if I'm going upstairs, I'm changing my EG, my height, right? So it's the change in gravitational energy over the time. All right. So the power is 147 watts that she can put out. And the EG would be EG2 minus EG1, the change in the gravitational energy over the time. And that would be 147 equals mgh2 minus mgh1 over T. Okay, 147, I can put in, well, let's think about this. At the bottom of the stairs in position 1, it's 0. This is actually a 0, isn't it? Because height 1 is a 0 at the bottom of the stairs. So it's really just the height of the stairs. So her mass was given as 30 kilograms. And gravity is 9.8. And the total height of the stairs is 60 meters. So this is how a lot of people solve this question. And now you just find out T, right? So 147 times T. And you multiply all the stuff on the other side there. 30 times 9.8 times 60, that comes out to 17640. And if you divide that by the 147, you get T is 120 seconds. Now, what this means is if she can put out this much power, she can change her gravitational energy by 60 meters in 120 seconds. But here's the catch. What about this 0.2 for the height of the stairs? Right? What if she has to go one step at a time? And this is where the confusion comes in. How do you go upstairs? Well, you can go up one step at a time or 2 steps at a time, but you can't ascend the stairs 1.5 steps at a time, can you? So when you think of it that way, it changes things. What we would need to do is we would need to figure out if she has 147 watts of power, how many steps can she take at a time? That's the catch. And of course, that's difficult to determine. The power, right, is the change in her EG over time. So what we could do is we could figure out the time it takes her to jump up 1 step. So let's do that. 147 watts. And this time for our, I'll just go back to here. This is how this would work. The difference is instead of going the total 60 meters, we're just going to use a height of 1 step here. So what you get when you're doing 1 step is her mass, which is 30 multiplied by 9.8 times her height. But this time the height is the height of 1 stair, 0.2, and you find the time. So now we get 147 on this side But because we're only jumping up one step, this is going to come out to a much different number. This is 58.8 joules per stair. So when you figure out the time for this, using the height of one stair only, it's going to be 58.8 divided by 147. That time is 0.4 seconds, right? And then that's for one stair. Well, how many stairs are there? So I'm going to just put one stair here. Well, if you have a height of 60 and each stair is 0.2, then you'd have to divide 60 by 0.2, and you'd find out there were 300 stairs. Right? 0.2, 0.2, 0.2, 0.2, 0.2, 0.2. Dividing that into 60 gives you 300 stairs. And 300 times 0.4 is 120. So we get the same answer if we assume she takes one stair at a time. But what if you could take 2 stairs at a time, or 3 stairs at a time? Well, the interesting thing is it really doesn't matter. It doesn't matter because, well, I guess it kind of does matter, but let's think about it. Let's go through that then. If you were to take 2 stairs at a time, well, it would all depend on how much you could jump. We don't really know if the woman can jump 2 stairs at a time because we don't have an indication of how much energy she can put out each time. We only know the power. And since we don't know the time, and we're solving for the time, 120 seconds, we can't really determine whether or not she can jump more than 1 stair. So in past years, students have provided answers where they assume she could jump 2 stairs at a time, and that's where the confusion came in. So you can do this one either way. You can figure out the total, like we did here, using the total height and get 120 seconds, or you can do it per stair and figure it out and then multiply at the end to get your 120 seconds.